our second session. Today's session, we're going to be looking at how we present data in tables and charts, which is part of the descriptive analysis, which is descriptions, how we describe the data by means of summarizing the data in a meaningful way. And then the following session, we will tackle how we summarize that data in numerical way. So in this week, we're going to look at tables and charts. And we also need to learn today's session. We're going to continue with the learning that we started the previous time in terms of the types of data, because you also need to know for what kind of data or what type of data, what kind of a visualization you need to create. What type of a table you need to create, or what type of a graph you need to create. Okay, so today we're just going to introduce how to develop tables and charts for categorical data as well as numerical data. By the end of the session, we will cover topics related to how you present and visualize categorical data, as well as how you present and visualize your quantitative data, which is your numerical data, and how do we interpret some of the tables, including the frequency table and the stem and leaf plot, which are more of your quantitative data. And we will also include some activities. Some we will do as groups, and then and I am back. I hope you all can hear me. I'm also going to switch off my camera because I'm load shedding, and I want to save up the battery as well as the bandwidth, because I'm connected via my phone. So let me switch off the camera. You must let me know if you can't hear me. Okay, so let's continue from where I think we left off. It was when I introduced this slide. You can also feel free to let me know if I need to go back a little, one step back. So whatever we're discussing today, it's part of your study unit 2, whether you're doing 1610 or 1510 or 1501. We're going to look at the two types of data. We've touched on the different types of data last week, so I'm not going to touch on that this week. So we have the categorical data, and for us to visualize those categorical data, we use the frequency table, a bar chart, and a pie chart. We're going to go into details in describing each and every one of them. To summarize the numerical data, we use an ordered array or a frequency distribution table. We're going to explain what each of those are. When we have a frequency distribution table or an ordered array, we can create a stem and leaf plot, a histogram, a polygon, or an OGIF, and we're going to describe all of them in short time. Okay, so for today's session, I thought let's start with real life example of data. So this is a sample of data from the questionnaire that I always submit or give previously the students who attend some of my tutoring or facilitation of learning sessions, and they will just give me feedback in terms of how they feel the sessions were. And they give in terms of, I did manipulate this data, but I'm not using the real, this is fictitious data, so don't make sense of it as if like it's real life, how people answered the questions. No, I changed some of the values as well so that it makes sense for the activities for today. But this will be the survey that somebody does if they work in HR or they work in education, and they just want to understand the quality of services that people have rendered. So you will rate our service. So this is the survey data. We're going to use this in all the example until the end. So it contains the module, the student enrolled, the gender of the student, the age of the student, and how they rated the, also this question, the last question, it's a made-up question. I just wanted to have something different. So this is a question on how they rate the quality of facilitation of skill, where 1 is strongly agree and 5 strongly disagree. So based on last week's session, based on the types of data, you should be able to look at this and be able to identify which data falls where, whether it's a categorical data or is it a numerical data. For example, module code, this will be a categorical data. Gender, it's categorical data. Age is numerical data. Rate the service or the quality of service in terms of facilitation session, 1 meaning strongly disagree and 5 being strongly agree. This is categorical data because it is data that can be placed into those categories, even though the coding on this question is 1 till 5, but those mean categories of either strongly disagree, agree, neutral, agree, and disagree, and strongly agree. So those numbers represent categories. So this is also a categorical data. So you cannot do summary of this and add them and divide them and subtract them because they are not numerical data. So we're going to use some of these columns for examples. So knowing the type of data that you have, you can also add the levels of measurements on here. So all of this is nominal, and this is numerical, and 0 means fail. So this, sorry, age, this is age. Age it's a ratio. Age is a ratio because 0 means you don't exist. And the rating of the session will be ordinal because it is in order from 1 to 5, which is the high levels, the ranking of that categorical data. So you can be able to identify different types of data from looking at your data that you are working with. So after we understand what type of data we have, we know that we have categorical data, numerical data. We need to be able to visualize it, because if you look at this, you cannot make sense out of this. You need to create a picture that somebody who looks at this data is able to understand what is happening at a glance. So at the moment, there are so many females, so many lines and lines of data. So we need to make sense of it. So how we make sense of it is either by visualizing it or putting it in the table. If it's categorical data, we're going to put it in a frequency table. And a frequency table is a table that shows you the distribution of your categorical data. And it will include frequencies, your relative frequencies, which are your frequency divided by the total. And your percentage frequency will be your relative frequency times 100. So you need to always be mindful of that. So a relative frequency, to get the relative frequency of QMI, there were 7 students who are doing QMI. We take 7 divide by 20. So that will be 7 divided by 20. It gives us a relative frequency of 0.35. And we take the 0.35, multiply it by 100, we get a percentage frequency of 35%. And you do the same for STA1510. It's 5 divided by 20. You get 0.25, which is your relative frequency. Multiply that with 100 to get to a percentage, which you call a percentage frequency, and you get 25%. What does that mean? It means there were 7 students who are registered in QMI. 0.35% of them are doing QMI, 35% of them are registered for QMI. That's how you interpret the data. We can also, for a categorical data, we can take that information and create what we call a bar chart. What is a bar chart? There is a picture of a bar chart. A bar chart is just placing those categories in those columnar bars, right? Each bar represents every category, and the height of the bar, which how tall the bar is, represents the frequency or either the percentage. With a bar chart for categorical data, the bars have spaces in between. Why I'm saying all this, it's because when you are writing an exam or your assignment, they will ask you about the properties of a bar chart. You need to know how to create a bar chart, and you need to know what a bar chart looks like and what makes up a bar chart. Not the bar chart. Oh, yes, a bar chart. Then we also have, I made a mistake here. This is a pie chart. Sorry, that should be a pie chart. And a pie chart, I'm still using the same category as a pie chart, but we can ignore this because this is a typing error. It's a repeat of what we have. So we can talk about a pie chart. Just want to see. A pie chart represent categories. It's also a categorical, representation of the data. The pie represent a whole, which cuts the slices, cuts or represents. These are the slices that represent, I'm going to call it slices. They represent either the frequency or they represent, sorry, the slices represent the categories, sorry. The slices represent the modules, which are the categories. That's categories. Writing it wrong. It's ES. Categories, which are the slices. So all the gray, the orange, and the yellow and the red represent categories. The size of each of these pie chart represents your frequency or your count, or it can represent your percentages. That's why I have 2 of them comparison next to one another. So the size, how big the slice is, represent your frequency or your count. So those are the things that you need to always remember when we describe what a pie chart is. And those are the 3 visualization you can do for categorical data. For a numerical data, we do an ordered array. An ordered array is how you summarize your data by placing your numerical values in order, from ascending order to descending order, from the smallest value to the highest value. And with an ordered array, it helps you to identify outliers on your data. It helps you to look at the range of your data, where you are able to look at which one is your maximum value and which one is your minimum value. And when you take the difference of those 2, they will be able to tell you what is the range of your data, which is the dispersion of your data. And we're going to discuss that next week in more detail, or on Monday in more detail in terms of the range, how you calculate the range. So with an ordered array, let's take our example data, our age. These were the ages that we had from the data set that, or our sample data set that we have created. As you can see, this data is not ordered. So before you even do any visualization with your data, sometimes you need to put it in order so that you are able to visualize it. So to put it in order, it helps us also to see which one is the minimum value, which one is the maximum value. We can see that the minimum value is 18, the maximum value is 45. From an ordered array, you can create what we call a stem and leaf plot. A stem and leaf plot is a visualization that groups your data, where a stem and leaf is made up of two things, two areas. Like it says, stem and leaf. It has a stem and you will have the leaf. If you think about a tree, the leaf from a tree, let's take the pine tree as well. You remember that you get a leaf, let's say a leaf looks like this. I don't know how to draw, but this is a leaf. With a leaf, there is a stem. This is a stem. This is what we call a stem. And there are some, this is what we call a stem. And then on the stem, there are some leaves, right? So this stem is what we're going to be talking about by saying it splits your stem from the leaves. So the leaves comes from this stem. So, but the leaves are different as well. So that's how stem and leaf plot is also going to be different based on your stem. So our stem on this one, we look at how our data is. So, and we always use our sorted data. So our data here was sorted. It starts from 18 up to 45. It's in order. So the stem will be the first digit, because our stem and leaf plot here, based on the data that we have, it's what we call a 10th stem and leaf plot. You can have a 100th stem and leaf plot, or a decimal stem and leaf plot, or 1,000 stem and leaf plot. What does that mean? If it's a 10th stem and leaf plot, it means there are only 2 digits. And with those 2 digits, you're going to take the first digit and put it as your stem. So you're going to look 1, 1, it's one stem. 2, 2, 2, 2, 2, 2, it's another stem, and we have 3, and we have a 4. So we've got 1, 2, 3, and 4, and you put them there. You don't repeat your stem. What repeats is your leaf. So how you build your stem and leaf plot? You first identify your stem, which is the first digit, and then you identify your leaves. Your leaves follows the stem, and they repeat. So here we have 18, 18, 19. All these 3 are part of the stem 1. And we're going to write the second digit as 18, 18, 19. And that's how you also read a stem and leaf plot. You don't say it's 8, 8, 9, because then when you are using this data and you're going to summarize it, you're going to summarize it wrong. So you must say this is 18, 18, and 9. So you must not forget to mention also the 10th number, or the 10th digit that makes up that number. So with the 2, you're also going to record all the leaves for all the 2s, and you do the same for 3, and you do the same for 4. And that is how you build a stem and leaf plot. If it was a decimal, your decimal becomes the line, and the first digit of a decimal becomes your stem, your second digit become your leaf. If it's a 100 stem, let's say you have the 10th and you also have a number that is 100. So therefore, it means you have a stem of a 10. You always remember that your leaf is only the last digit. So if I have 100, so that one would have been a 10 and then a 0, which represent the 100. You will write it that way. And that's how you write a stem and leaf plot. Okay, moving on. So with a frequency distribution table, which is also still, we're doing a numerical table. So a frequency distribution table is a frequency table that summarizes numerical data. So using the same data that we have of 20 students who responded to that survey, we're going to use their ages in years and create this frequency table. How did we create it? This is how. We take that raw data that we have in an order. It has to be ordered. We first have to find out what is the range of this data. And we found that the range is 27. We need to also determine how many categories we want to create of this data. So we're saying we want to create groupings of this data. But we're not just going to thumbsuck them. We want to use the proper steps. We also want to make sure that the groupings have equal width, which we call a class width. So in order for us to create this class interval, then we need to say, from our range, we're going to divide that range by our number of classes that we want. So if you take 27 and divide it by 4, you will get something like 6.75 or something like that. You can either round down or round up depending on how clean you want to create your class intervals. So because I want to create clean intervals, I'm rounding up to 7. So it doesn't mean that 27 divided by 4 is equals to 7. It means I am trying to look at the computed class interval, which was 6.75. How can I make the classes clean without having decimals, point something at the end, or 0.3 and 0.7 at the end, but making sure that I have a clean class interval. So I'm going to round up to 7. So I'm going to say the difference between my lower boundary and my upper boundary should be equals to 7. So if I count from 18 to 25, it should be equals to 7. Once I have determined my class boundary, my class interval width, then I can create these limits. These are what we call the limits. The first limit will tell you, you can use the open bracket and the close bracket. The close bracket means it includes that number. The open bracket means it does not include that number. So if I'm going to create class boundaries, I need to create 4 classes. So the first class, I look at my data, and I say, okay, my data started at 18, so I'm going to say 18 plus 7, I get to my 25. Oh, sorry. What did I say? I said open bracket means it includes, close bracket means it does not include. Okay, I'm interpreting this all wrong. Open bracket, close bracket, open bracket, close bracket, close bracket, and open bracket. So it will mean it must include that number. I think then my thingy at the end, this one should be open bracket. It should not be close bracket. So I've done them vice versa. But my class boundary says the values should start from 18. In this way that I've made it, I'm saying it must start from 18 and include 25. So it should also include not less than. So it should be from 18 to 25. I must check what I did on here. So that will be my first class. My second class says it must not include, also I will have to change all this. it does not include 25, but it includes 35. That's how I created this. So open bracket means does not include, close bracket means it includes. So this, the third one will say includes, does not include 32 and ends at 39. The second one, 39, but not up to 46. So it does not include 39, so it will be 40, 41, 42. So that's how you create the class boundaries. I need to change my notes. I realize now that I've got lots and lots of errors on my notes now. And once you have calculated your class intervals, then you can then start counting how many, which is the frequencies. So for example, we said that I'm going to use, I'm not going to use the notes on the step number 4. I'm going to use the class intervals as I created them here. I'm saying it must include 18 because 18 is my first one, 18 up to 25. So I'm going to count 1, 2, 3, 4. There are 4 of them, and then I write the 4. That's my frequency. It does not include 25, so it's 26, 27, 28, 29 up until 32, 26 up to 32, so it will include all this. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them. And 32 does not include 32, so it's 33, 34, 35 up until 39. So up to 39, there are 1, 2, 3, 4, 5. And I write there 5. And the last 2, which is from 40 up until 46, it's 2. And I write it there. And that creates a frequency table or a frequency count. To calculate the relative frequency, we do the same. 4 divided by 20 gives us 0.2. To calculate the percentage, 0.2 times 100 gives us the percentage, and you complete the entire table, where 2 divided by 20 is 0.1 times 100 is 10%. To calculate a cumulative frequency, we say the first interval will be the same as the number of frequency that we have. So we put there 4. The second interval will be 4 plus 9, which gives us 13. So you take the previous value plus the value of the current class interval, and that gives you 13, and you continue doing that. 13 plus 5 gives you 18. 18 plus 2 gives you 20. And to calculate the percentage cumulative frequency, you just say 4 divided by 20 and 13 divided by 20 multiplied by 100 will give you 65. And that is your frequency distribution. You need to know how to complete a frequency distribution or how to create a frequency distribution. There is an activity at the end that we can look at. From a frequency distribution, you can create what we call a histogram. A histogram is almost similar to a bar chart, but for numerical data. There are no gaps because if you remember, when one interval starts, the other one, when one ends, the other one starts. When one ends, the other one starts. So their interval are overlapping on top of one another. When one starts, the other one starts. There are no gaps. The height of the bars represents your frequency, and your bars represent your class intervals, right? So that is a histogram. From a histogram, you can create what we call a polygon. Oh, you can also look at the shape of this histogram, and you can see that this histogram looks skewed, and it is positively skewed by looking at its right skewed, or what we call positively skewed. By looking at this, it can tell you what the distribution of that data looks like, our age distribution. We can create also polygon. To create a polygon, you need to create a midpoint, and with a midpoint, is just taking the midpoint of the class interval. So 25 plus 18 divided by 2 will give you the midpoint. And we're going to use the midpoint to draw the shape of a percentage polygon, which is just a, you can use percentage polygon or you can use frequency polygon. Here I'm using frequency polygon, but you can also use the percentages. You can also calculate a cumulative percentage polygon. Here I'm using the actual frequency, so you can also create a cumulative polygon where you also look at the lower boundary and add up all the values. So this just takes the frequency, cumulative frequency column, and you just create a line chart, or you can use the frequency, cumulative frequency percentages and calculate your OGIF. Okay, so that ends my summary. Any questions? Then we go into the activities. Are there any questions? No questions? Jeanette?
No questions. Thank you, Lizzie.
Okay. See you. Okay. So if there are no questions, let's see if you are able, based on what I've just said, if you are able to answer these questions. Question number 1. Looking at table 1A, firstly tell me, what does table 1A represent? Or what is the type of ASD? What type of data is ASD? Yes.
I raised my hand.
Oh, I can't see your hand. Okay, sorry. Yes, you can go ahead.
Okay, I have one question for you.
Yes.
Can we go a bit back to frequency distribution? I just didn't get the part where we calculate the cumulative frequencies.
Okay, so to calculate the cumulative frequency,
Yes.
the first class interval, right? The first category of the class interval, it will be the same as your frequency.
Okay.
The second value here, it will be the cumulative frequency, maybe because I'm using the 4 here, it needs to be plus that number should give you, so you're going to add them. They will give you 13.
Okay.
Take this, 13 plus 5 will give you 18. 18 plus 2 will give you 20. If you calculate your cumulative frequency and you get to the end of your class interval, and the value you get here does not correspond to your frequency total, then there is something wrong that you have calculated. You can use that as your checks when you calculate that. Is that clear?
Okay, now I get it.
Okay, so let's go to our question. What type of data is this? A, B, C, D, E. Is this numerical or categorical data?
Numerical.
A, B, C, D, E. Is it numerical or categorical? Numerical is numbers. Categorical is categories. Type of ASD?
Is it not category?
It's categorical data. So if you know about categorical data and it's categorical data and what we have just discussed right now, what type of a table or a visualization this then becomes? Is this a frequency distribution? Is it a relative frequency? Is it a frequency table? or is it a cumulative frequencies? Remember, there are 3 types of visualizations you can do. Let's go back to the first picture. Maybe let's come back here. Let me refresh your mind. In summary, for categorical data, we use a frequency table, or what we call a summary table, frequency table or a summary table, a bar chart, and a pie chart. For numerical data, we use an ordered array, stem and leaf plot, a frequency distribution, a histogram, polygon, and OGIF. Okay. Okay, so now let's go answer our question. Table 1.1a refers to 1, 2, 3, or 4.
I'm going to say 3, let's see.
It represents number 3, frequency table, because it only frequency distribution is a numerical frequency table, right? A relative frequency, it's a calculation, it's not a table. It's a calculation done. You can calculate it on a cumulative or on a frequency table or in a frequency distribution table. A cumulative frequency is also a calculation done on a frequency distribution table. So these are calculation, and this is for numerical data. Only frequency table. Okay, so these are the types of questions that can also be asked based on the frequency table. So we know what the frequency table is now. It's table 1.1a. Which one of the following statement is incorrect? So we need to validate each of this statement to choose the correct statement. So it means we'll have to go through each statement and answer it and see if the number that is on there is the correct number. So number 1 says the total number of people living with ASD is 500. How do we get that number? It's by calculating the total. So what I will suggest you do is take out your calculators or your phones and calculate and see if we've got 500 people on this list. 108 plus 44 plus 206 plus 85 plus 57 is equals to 500. So knowing that we have 500 people on here, therefore that answer is correct. You're going to validate it in that way. The frequency of people living with type B of ASD is 0.09. Do you know how to calculate the frequency? You don't have to calculate the frequency most of the time because it's the count. The number of people is the same as your frequency. So how many, or what is the frequency of people living with type B? That's how many number of people living with type B. So this is the incorrect one. So we found our answer because the frequency of people living with ASD is the same as the number of people living with ASD, which should be 44. The relative frequency of people living with type C, now they are asking you to calculate the relative frequency. So how do we calculate relative frequency? Relative frequency of type C will be given by 206 divided by 500. How much is that? What will be the answer?
0.4.
0.41.
0.41, which makes that value correct. Number 4, it says the frequency of people living with type B is, type D is,
85, which is correct.
which is correct. And that's how. And then the last one says none of the above statement is incorrect. That is correct. No, I don't know why they say none of the above. It's very confusing, but you can just ignore that last statement. But that last statement says it means all these statements are correct, which then it means it's correct because I don't know how to interpret that last one. Okay, so let's look at another question that they might ask in terms of you being able to look at the information and interpreting what you see in front of you. So, what will be the appropriate graphical form to summarize this data? We said type of ASD is a categorical data. So if we know that this is a categorical data, which one? Number 1, number 2, number 3, number 4, or number 5? Remember of everything that we discussed today. If we didn't talk about it today, it means it's not the one.
Number 3.
It will be number 3. You can either use a bar chart or a pie chart. Moving on to more other complex questions. So on this one, I turned around what do you call that thing now? The multiple choice question into a normal question so that I must demonstrate to you how to answer and interpret a table that looks like this. At the moment, what you are looking at looks so weird, right? Based on what we just went through. The frequency table, I just told you that the frequency values will be given to you. There's no need for you to calculate. In this instance, you have to calculate that because they are not given here. But how do you calculate your frequency table or your frequency distribution based on these few values that they are giving you? We can complete this in short. Remember, the cumulative frequency of the first one, right? The cumulative frequency, because I cannot calculate the total here. They didn't tell me how many they are, in how many frequency people are there. I know that this is out of 100%, but I also know that the cumulative frequency, which it's also having missing numbers, the last value of your cumulative frequency should be the same as the total. So I can freely say there are 25 of them on there. Automatically, I already have one value completed, but that does not solve your problem. Your problem is solving this value that is on here. And this value there, and that 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 value there. So let's start with the top one, the frequency on this. So what we said is the first frequency value is the same as your previous frequency. Your first frequency, your cumulative frequency is the same as your frequency value. Your second value here, 7, is made up of the second frequency plus the cumulative frequency of the previous value. So to get 7, we said 4 plus this value would give us 7. In order for us to get this value, we can just say 7 minus 4 gives us 3, because 3 plus 4 gives us 7. The same. Seven plus this value here should give us the value here. I don't know what that value is, so it means I cannot calculate that frequency. The other thing that you can calculate, which is easy to calculate at this point in time, is your percentages. So we can calculate the percentage there and the percentage here, but we can also calculate. No, we can, because I don't have the value here, I cannot calculate the value here. So we're gonna skip that one for now. And because I don't have the value here, I cannot calculate that value there, which also makes it very difficult to complete. So, but let's look at other values that we can compute. This table, it's so weird. Which other value can we calculate?
Can we calculate the frequency percentage for the first line item?
Yes, we can.
So would that be 4 divided by 25, which is 16%? Roughly.
Yes, that will be 16%. So all these are percentages. And 3 divided by 25.
Does it give me a point? 3 divided by 25. Supply 100.
It's 12%. So that will be 12%. Probably all this should be easier for us to answer the question. Let's see if we can answer the question. Oh, we can also answer, yeah, this 10 divided by 25. It's 0.4, which is 40% times 100, it's 40%. Which is 40%. We can actually be able to calculate the other values as well as we go along, because 24% of 25, we can calculate that. So we can say 0.25 times 25 gives you 6. So 6 divided by 25, or 7. 7 divided by 25. No.
Actually, you lost me there.
0.24 times 25 will give us the frequency of, yeah, so which is 6. Because 6 divided by 25 is equals to 0.24 times 100 is 24%.
Oh, we vice versa.
Yes, I vice versa it. And 25 minus everything else will give us the frequency of this value here. So we say 25 minus 10 minus 6 minus 3 minus 4 equals 2. So we have that. So we can complete the entire table, but I'm looking at the time now. So 2 divided by 25. 2 divided by 25 is equals to times 100 is equals to 8%. So that will be 8%. And we can complete the entire table. So 7 plus 6. 7 plus 6 gives us 18. And 18 plus 10 gives us 23. And 23 plus 2 gives us 25. Yay, we were able to complete the entire table. Sure, based on the values that they have given us. So let's see if we can answer these questions. So number 1, What percentage of the staff members earn between 25 and 30? You go to 25 and 30, between 25 and 30 rand. And they say because they're asking for percentage, so we're going to go to the percentage and we're going to say it is just 8% of those staff members. Number two, how many staff members earn more than 15,000? So because they talk about more than, then we're going to use the cumulative frequency. More than, we're going to come to the cumulative, and because they're looking for how many as well. So 15 and above. So we're going to take all these 3 class intervals. So they are, we're gonna add all of them because we're looking for the frequency. Well, we're not gonna use the cumulative frequency. We're going to use the actual frequency, because if we use the cumulative frequency, you can see that it's 13, 23, and 25, right? So the best way is to use the frequency. So we're going to say, if they would have said less than, then we would use the cumulative frequency. Would have used 7, but it's 6 plus 10 plus 2, which is equals
18.
to 18. So there are 18 members who earn more than 15,000. What is the sample size? How many are they?
30.
There are 25. Your sample size is the sample that you are working with. There are 25. What percentage of staff can earn less than 25,000? So this one you can use the cumulative because it says less than. Less than means from here upwards, because it says less than 25. So you can come to your cumulative frequency, but remember they're looking for a percentage, right? They say less than 25,000, so it will be 25, 20, 15, and 20, all them, which are 23. So you're just going to say 23 divided by 25. Oh, don't forget to multiply by 100 because it's a percentage. And that will give you 23 divided by 25 times the 100. It's 92% of the people and that concludes the session. But before we conclude the session, if you do have time, you can take a screenshot. Here is another example of the activity that you can do on your own. You can do this one on your own. And are there any questions, comments?
The notes that we used today, did you post them?
Pardon?
The notes that we used today, do we have them? Did you send it to us?
No, I haven't sent the notes. And that concludes today's session. I just want to also take you through other questions that are on there. The schedule. We are on Monday, we are discussing measures of central tendency and measures of dispersion, and see you on Monday. But before you leave as well, remember to always register for the sessions so that you can get the Teams link. I just want to tell you something, especially those who joined for the first time today, that I'm giving all these sessions for free, and I work for a company called Pambili Analytics, where we're building capacity in terms of statistical literacy, data literacy, and numeracy. But not only that, I do business intelligence consulting, market research consulting, as well as research consulting, right? We offer different kinds of services, not just only the skills training and development in terms of what the kind of things that we do. We, most of our training, we charge per hour, which is instructor-led. And we also have training on self-service led, which you have to register and join on our LMS system and go through the training on your own. We're running a special of 150 per month or per hour for a session. Usually our session are 350, but this type of a session, if you want to book a one-on-one session with us, you need to do that, and we charge 150 per session. But these sessions that we are attending are for free. How do you access the recordings after the session? Even though we offer them for free, remember also we do have a YouTube channel, or I do have a YouTube channel. You can go to my YouTube channel and subscribe. There are free videos there, plenty of them. Plenty of videos that actually supports the learning. You don't have to or to become a member on my channel and contribute. The only way I survive is by means of your contribution. And thank you to Giselle. I might say your name wrong. Forgive me for also being part of the members. Yeah, thank you for supporting me. So when you go on the YouTube channel and sign up as a member, you actually are saving a lot of money, because remember, this session I offer them for free. Actually, you should be paying 150 rand per hour that I spend with you. But if you go there, you sign up as a member, you get the video for 79.99, depending on the type of membership you have. Please do not choose the other first two. The first two are for cheerleading and supporters. You need to choose either all this. They've got different categories in terms of access to the videos and other perks that you receive. Otherwise, if you want to have one-on-one consultations with us, feel free to reach out. We do have an email, a WhatsApp, as well as the website. You can get hold of us in many different ways. I just wanted to stop right there. Are there any questions?
Not for me.
Thank you. If there are no questions,